Well, hi, good morning. Thanks so much for joining me here in my shop. Oh my gosh, what happened yesterday in here? A lot of craziness went on in the shop yesterday. But there's one major, I don't want to call it an error, really something I forgot about that would calm all this down. And that is that when I tune my SDR radio above 25 megacycles, it no longer behaves the same way. It needs to be reconfigured above 25 megacycles. So when I saw that signal at 70, 71, it meant nothing. It meant nothing at all. Yeah, so ignore all that. But I was in here last night trying my best to get a stable image onto that oscilloscope, and I managed to do it. And for crying out loud, it hasn't helped me one bit. So I'm going to try to get that back up on the scope this morning so you can see it. And then I'm going to ask the big question, does any of this really mean anything anyway? So my scope is just idling there. It's scanning at its top rate right now. The sweep speed is at maximum. That's a 0.02 microseconds per division. I have the brightness turned up quite a bit so you can see it. Let's turn the radio on and just see if it doesn't come right back to where I left it. I hope so, because okay. So the input is set to AC, so you can see the DC kind of charging up the capacitor inside the radio. It's interesting how many it went up and down and down and up and down. Now, come on. Show me, what was that? That was a wild thing. Come on, you can do it. So to get this onto the scope, what I ended up doing was changing my scope leads to try to get a little more signal onto the scope. Come on, man, you can do it. Don't leave me hanging here. Let me put the closer camera in while we're waiting for everything to come to life here. It's there. It's coming. I can see it. It's very, very faint. So maybe I'll just switch cameras here. Get a look at it there. That's not what it looked like last night. Holy smokes. Again, I'm not so sure this is even important for the radio. Let's turn this up a bit here. There, now I've got the brightness turned way up on it. No, that's not quite what I saw. Well, so it's similar in a sense that it's not a consistent signal in terms of amplitude all the way across. It's got this funny thing going on in it. Frankly, I don't know why I won't even describe what was there last night. I have a photograph of it. I can insert in this video if I remember to. Of what it looked like last night. So there we are. What is that exactly? How can I come to grips with the frequency on there? The frequency of the wave shape on the scope. I don't know. Okay, I am going to stop for a minute and consider whether this track is worth going down any further, or whether I should lay it aside. Maybe it'll raise its head somewhere down the road. Yeah, let me stop for a little bit here. Okay, so I thought this situation through, and I decided the best thing I can do is get back to what I was doing when I encountered this mystery signal, if you like, and that was I was getting ready to trace radio signals through the radio to see if they were for the short wave bands that are weak, to see if they were stopping at some point, or you know, just do the basic signal tracing thing. And then I encountered this other signal, whether it's real or not, and that's where I've been. Yes, Fantasy Island, a place I love to go. But I'm leaving it now. I'm going to come back to reality world. I'm just going to well, semi-reality world, because I'm going to use the SDR radio. Who knows what kind of confusion that might create here as I try to trace the RF signal through the radio. Okay, so I'm going to get things set up for that. Good luck to me. Yeah, and another factor just came to mind here. The other night I decided to just quickly, with my ohm meter, test a bunch of the resistors that are in this radio. There's a lot of 100,000 ohm resistors and quite a few 1 million ohm resistors. And they all of them measure about 40% high. And one of them is double. 1 million ohm resistor is actually a 2 million ohm resistor. So in the back of my mind I'm thinking, boy, I've got to do something about all that too. 40% is kind of getting out there. And some of these resistors could be in a position where a 40% or certainly a doubling could be a big issue with the radio too. So I've got that in mind. I don't normally poke around with resistors too much unless something draws them to my attention. But this time I went through them and that's what I found. Oh boy. Okay, I think I reached an interesting point here with this radio. So we're just about ready to start signal tracing, where I want to feed in a shortwave signal like shortwave broadcast station would, and with my SDR poke my way through the circuit step by step, starting with the antenna, just working along and watching what happens to the signal. So the first stage is to get this tuned into some signal. It seems like no matter what I do with my signal generator over there, you see it's on 14.2 right now. I can't detect it over here. I cannot detect the signal. I got my signal generator turned right up. Well, not quite, but close anyway, close to everything it's got. So what I'm going to do is I'm going to determine what the local oscillator frequency is in the radio, and then I'll know where the radio's tuned. Then I can tune the signal generator to that, and then I can pound it into the radio and make it come out of the speaker, and then I'll be ready to trace the signal and try to find out where it's not going. That's the idea. So first thing is, what frequency is the local oscillator at? So the way we're going to figure this out is using the SDR radio. And this pickup coil here. Let me just plug it in over here. Now somewhere along the line, while I'm using my little SDR radio as a instrument here in my shop, I'm pretty sure I'm going to blow the front end right out of it someday and just make a little mistake and it'll be gone. But you know, those radios only cost $25, so I should have bought two and had a backup one. But so far I have not blowed it up. Maybe today will be the day. So this is now the antenna to the SDR radio. I'm just going to put it near the oscillator coils, and we should be able to fairly quickly figure out what exactly the local oscillator frequency is. Now the capacitor is half open. This is I think it's 6 to 18 megacycle band, so it's somewhere around, let's say, 10 megacycles. So the local oscillator would be roughly 500,000 cycles above that. Let's take a look and see what we can see here. Okay, so we'll calm this guy down to around 10. Often the local oscillator signal is so strong I don't even have to get that loop too close to the radio to see it. So I don't see anything on here now. Let me move the loop in with the oscillator coils. Oh, look at that thing just came up. A couple of them. That's not good. Now again, if you're going to try this with a cheap SDR, you're probably going to run into the difficulties I've had, where the SDR has piles of ghosty signals. So let's see. So I'm going to tune the radio. The way I can pick out the correct signal, I have learned, is they kind of travel across the screen at what seems to be the right rate. So, you know, I'm tuning the radio. I can kind of gather, you know what, I can't tell which one of those is the real guy. Look, they're going in different directions even. Okay, I'm tuning the other way. One of these is the real local oscillator. Let's go to the extreme end of the band. one end of the band. And we know roughly what the oscillator should be. So where am I getting to? Okay, so I'm closing the capacitor. Capacitor's closed now. And which end of the band is that? I can never remember. Well, the band is, I'm just going to check the glass dial here. This band is actually 6 to 18. So we're either near 6 or we're near 18. Well, I don't have to think too hard. Let's go look. Near 6. Okay, so big thing right there. Let me tune the radio. This might seem like a kind of a crazy way to come to grips with this. So there we are. So I think that red one here is the right one now. So if we were right at the end of the band, this would be about 6/455, somewhere down in that area. I think this is it. So assuming it is, we will set this now to a selected frequency. How about somewhere towards the middle of the band? 10/455. Let's go to there. 10/455. I don't want to lose track of this, so we're going to watch it go all the way up there. Not that way. This way. Okay, we'll let it go off the screen a little bit. Pick it up. Somewhere in here. Where is it now? Okay, so there it is, right around 9, I'm pretty sure. But we want to go to 10, so we'll go up towards 10. See, there's lots of weird signals on these things. But with experience, you can sort it out. So there's 10, and we want to get to 10/456. That would be, I'll put the red line right where we need to go. Okay, now just put the local oscillator over there. I'm tuning the radio again. One way, other way. Okay, we'll know for sure if this is really worked out. And we'll just line it right up on that. So in a sense, the radio is now set to receive 10 megacycles at the antenna. Once I get this right on the money here. Okay, quick review. Local oscillator running at 10/455, radio ready to receive at 1 megahertz. So we'll put in a 1 megahertz signal and see if we can hear it. Megahertz. Volume up. Volume up. Volume's up everywhere. Power's not quite full, but close. 14 down to 10. Listen very carefully at 10. I didn't hear a thing. Okay, so decalibrate the signal generator and pump its power up. Nothing at all. What's gone wrong here? Okay, so an awful lot of you have been saying band switch, band switch, band switch. I was even going to focus on that before doing this, but I decided to do this before fiddling with the band switch. So I'm just going to twist the band switch a little bit and see if it doesn't actually pop in now. This is a good test of the band switch, which my impression is the band switch is working fine. That's my impression. Even though the radio's not. So this is the highest band. This is one I've never heard anything come through on yet. I'm pretty sure about that. We know the local oscillator is working. Is it possible that I've actually, the local oscillator is not where I thought it was? That's quite possible. What a hassle doing this, eh? All because the dial is missing. No, if the dial was missing, I'd just read the dial, the pointer. Not there. So, well, I now have my signal generator full tilt. Let's just sweep the whole band around 10 megahertz in case I missed it a little bit. It's close to 10 for sure. Very quiet. That's just absolutely nothing. Have I done something dumb here? Do I? Yeah, I have. Okay, so we've been on the antenna all this time, not on the signal generator. Okay. Duh. Let's put on the signal generator. Turn it down. Okay, so this should make it work. Hey. Some mistakes are very fortunate. Now, I think this is tuned to 10. Let's try again. On a fairly low signal. No. Up. Oh. There he is, finally. Okay, so I decalibrated this. Not that it was really well calibrated to begin with, but you have something like 1,000 times 10 microvolts, 10,000 microvolts, 10 millivolts on the antenna. That's a pretty strong signal. That would be like receiving a strong signal off your outdoor antenna, something like that. The volume is turned up, I think, full, is that? Full blast. Oops. Full blast on the volume. Some of my audio clip leads are just a little loose here. That's why that's going up and down. That can't be right. This radio should be producing a really clear sound at this point. So possibilities are misalignment again, and so we'll check that quickly. Not to align the radio properly, but to make it work as strong as possible right now. And see if, I've done this once before, but I'm going to do it again. So we're on the high shortwave band. That's these coils up here. Oscillator. See, I actually wrote it so I can't forget. Oscillator, RF, and antenna. Let's adjust the antenna first. So you see there's a little bit of a bump up. Again, this is not a proper alignment. This is just to make sure the radio is not. So a little, just a touch of an increase in here, but nothing dramatic. I mean, this normal listening volumes. This is what this radio sounds like. Well, that's with a strong signal coming into it. And my system volumes here. Sounding. I'm pretty sure if this was switched to AM and we tuned in a station with a decent antenna, it would be blasting out of this radio right now. So I don't think there's any doubt it's weak. Good. Now the trick is to try to trace this signal from the antenna on through the radio, starting right at the antenna on the SDR. Okay, so let me get my video system set up to make this kind of fun to do. Okay, so as a start, we'll just sniff around and see if we can get anything to show up at 10. And I'm going to start right back here by the wire. So 10, sure enough. So that signal at 10 that's just come in, and now it's gone. Back is coming from me just laying this coil up against the wire from the signal generator. So there's no so that's what that looks like there. I don't think I can do much more with this coil, but so let's just poke around and see what happens here just before before I switch to another technique. So that should be in this coil. You see the color is red. It's a little bit reddish. It's stronger here. Now, this is a real clumsy way of doing this, so it appears to be stronger at this point. Now from here, you know, good luck. It heads up to a vacuum tube and then shows up in these coils right over here. See, the local oscillator is really apparent at 10, where the red line is on the top of the SDR display. But what happened to the radio signal at 10? Where is it? Something there at 10-100. Let's go back here. We're still. So there's the signal from the antenna visible on the antenna coils at 10. From there it goes through the RF amplifier, comes out, and goes through another set of RF coils. These ones. What happened to the 10? And where'd that other thing come from? So it could be moving this around. I'm tuning and retuning the radio a bit. Shouldn't cause things to move around though. It should just make them stronger and weaker. Well, that's a surprising result, but maybe not. So what I'm doing is at first I'm touching these coils here, and then I'm touching these coils, and in between them is this tube. I think the purpose of the tube is to amplify the signal. Sometimes these are more involved with changing the impedance, so you have a very, very high impedance antenna. You can't draw anything from it. After this tube, it's a lower impedance arrangement. You can draw more from it. Something like that could be happening. It's maybe not stronger in the sense that the voltage is up. Maybe stronger in that there's more juice to it. But I would have just guessed what you see here, you see more of here. But we didn't. We didn't see more of it. So that certainly implicates the situation right around in here. So let's try the band switch a little bit again. Now we should hear it come right out of the speaker. If the band switch is in trouble, we're going to hear this thing jump up and down. But let's fiddle with it. Let me just make sure I'm not. I have both hands in the radio here, and that's just a little bit dangerous. Okay, looking at 10 on the SDR. You know, it's just slowly turning it. So see, I killed the local oscillator, the signal disappears, of course. Wait a minute. Yeah, there is no signal at 10. Well, there should still be a signal at 10. Shouldn't there? Oh, these coils get grounded. Yeah, it's gone. So probably turning the band switch is enough to ground this coil out. Let's go back. Well, it sure gives me the impression that it doesn't even make it from here to here. Okay, let's try this on another band, one that is not so sour. This one seems to be quite sour, so we'll go one band back. That's the shortwave band from 2 to 6 megahertz. Okay, we'll go there. Let's go there. So you can hear radio sounds now. I mean, that's telling me this radio is working at this point on this band. But let's do this test again and just see if it doesn't. The signal doesn't transfer. It doesn't transfer to here. Transfer from here to here properly on this band. So where are we tuned? Somewhere in the middle, somewhere around 4 megahertz. So I'll change this to 4. There's where it is. You can see how much stronger that is. I'll turn it down. So this is now a moderately weak signal supplied to the radio. Most radios would receive it. This one seems to be receiving it fine. We'll give it a weak signal. So this is now a fairly weak signal. You can hear that what's happened is the AVC voltage dropped and the radio's sensitivity at the front end is increased, so we're hearing noise now. The signal sounds the same. That's just what you want. The radio's AVC is operating, even though the input signal is changing. The sound in our ears, the tone sound, is pretty similar. So this band appears to be working beautifully. Let's hunt it down on the SDR now. We're at 33. 3.3. So somewhere around this red line we should find the signal. Where's my oh, that's what fell. Okay, so here's the coil from the floor. First I'll put it by the signal generator wire. Okay, so at 3.8 I saw something show up. Yeah, 3.8. So it's up in this part of the display here. 3.8, 3.3. So 3.8 is the local oscillator frequency. Yeah. So where's the 3.3? I may not be able to pick it up this way. Holding a coil next to a piece of wire is not going to do it. I'll boost the signal input strength. Okay, AVC has quieted down the radio. Tone ended up a little louder, and that's okay. Put this near that. No, see, it's just not going to show us the actual 3.3. Not this way. So make sure that's connected there. Was that not connected? I can't see anything at 3.3. Okay, so we're now going to use alternate method instead of using. Oh, let's keep using this. Let's keep using this because we're going to be fooling around with this coil here. Okay, I see it. It's just popping up just to the left of the red line. Right. Just barely see it poking its head out of the side of the mountain there. Right above the letter R in the word shortwave broadcast. Shortwave broad. Just a little tiny peak there. How am I going to see that on the net? Well, it's supposed to be bigger on this one. So the local oscillator is getting in there. Okay, so, oh, look at that. See the peak come up there? How did I do that? I did not. Don't bang these things around too much. So there's a good view of it there. Easily visible in here. You see here, I can kind of get it up to around the minus 40 dB level. And this one, I can easily get it up to that level and beyond. So this is working the way I would imagine it to work. The antenna signal is driving this coil, and then after the tube, this coil is being driven stronger. And I can pick it up easily with this. So this again suggests that on the other band, there's a problem between here and here. On this one seems to be working quite well. It really does. I don't think there's a problem on this band at all. The other one was long wave. I had the impression long wave wasn't working, but I also mentioned who cares about long wave anyway. I think there's still some ship beacons running on the Great Lakes, but so again, I'm going to skip the long wave. Really, time spent on this short wave band is much more productive. So what I'm thinking about is, what if I contact these with my SDR, take the coil off, put on a padded connector, and actually touch on these coils. This is a low impedance thing, so if I were to hook up the ground and the lead wire, you know, do the usual thing, that would definitely. But with just the wire sticking out, what would happen? Something handy here. What did I do with it? It's all ready to use for this. resistor in there too, man, just to guard my SDR. So in these first, you know what? There's really no voltage here. Let's try it. Let's try. I can always buy another SDR, can't I? We're only going to hook up just the center lead. It's through a capacitor. Surely this is going to blow the whole thing up. Famous last words. Yeah. Starting at the antenna. Let's put it right on the antenna and see what we get here. So I can certainly see the peak, again, in the same spot, right above the R in broad. So now the problem is the signal comes in the radio and goes through circuits that are located way up in behind these coils. So if I were to try to get to the, let's see, the end of the antenna wire can't be the problem. The problem is band local. It's only one band. That's a big hint. One band. One band would be, which band? Pretty sure it's this one down here. I'm just pointing to the local oscillator coils. This is really where the trouble would be, Jeff. So yeah, band switch is possible, though I don't think it's very likely at all. There hasn't been a moment where I've operated the band switch and thought, wow, this guy's wacky. So we could have a problem. This coil, you know what? I learned a lesson a couple radios ago. The shortwave is usually hooked up to a long wire antenna sticking out the backyard. That makes this coil very susceptible to lightning effects. And you don't need a bolt of lightning to hit the antenna. It just has to hit nearby and cause a ground potential rise, which will in some way get impressed onto the front of this radio and burn that coil out. So what I would need to do is measure the resistance of these coils, see that they're not open. Yeah, look for an open coil. Maybe that's the very first step. So this switch is set incorrectly. This coil is shorted by the switch. So I have to have this switch to this band, and then I should be able to measure this coil we're looking at is right here. Most of the terminals are kind of hidden around in behind. Man, am I going to be able to do a test there? That's going to make sense. So we have the capacitor trimmer sitting on the secondary, so I can actually just go across the trimmer and I will test the secondary. But look at the wire in that thing. It's a great big coat hanger wire there. Even the wire on the other side, the antenna side, is not so fine either. So the antenna signal should be blasting in here. Let's go back to the 10 band. Back to the 10. Okay, so we're now on the shortwave band. I'm going to retune to 10. Did I tune the radio? I don't think I tuned the radio at all, did I? Turn it up. Turn it up. There it is. Ooh, sounds distorted, doesn't it? Sounds like something's being overloaded. Oh my gosh. Well, that was pretty interesting. Okay, you couldn't see what I did there, but that was quite interesting. I'm going to turn the output up on this signal generator. It's going up. happening here? Has this radio started working? What's happening? Okay, what is happening? Where's the volume? Volume's full. Signal is strong. Jeepers creepers. It's okay, let's put it on a regular antenna. See what it sounds like. Last time it was just silent on the regular antenna. On the irregular antenna. Signal generator off. I still think it's weak. Anybody hear anything? So yeah, does not sound like a radio to me. Expect to hear quite a bit of hiss and crackle now. No hiss, no crackle. Okay. No, the radio's not working. It's just a very, very strong signal is making it through. Okay, back to our testing here. Let's just double check. Make sure we do this properly here. Okay. Right on the fine wire coil of the shortwave antenna thing, and we're looking for a 10. Wait a minute, I got this wrong. 10 is here. Something should come up there. There it is. So we go from there over to the secondary. It's in the same pannier, no difference. Now we go to the next coil. Hear the radio come to life. Well, isn't that interesting? Let me inject a signal. Okay, I didn't get a shock there. That was the sound made me jump. What the heck was that sound? Okay, let's just everybody man your volume controls. Everybody man the volume controls. Let me turn this down a little bit here. Loose coil. I barely touched this thing. Magic finger. Okay, I'm insulated from ground and everything. There shouldn't be any voltage here anyway. You know what? Could be there's some insulation missing. That's really interesting stuff. So I think what I'm doing is I'm using my wet and moist finger to discover breaks in the insulation on that coil. And I just happened to touch one when I put my finger on it. Exciting stuff. So once again, going back here. You hear the signal come in. So what this is suggesting to me, because I can hear this, is that in fact I'm skipping the front end of the radio and providing an antenna right onto this coil, and then the radio is carrying on from there and working quite normally. So that's another indication that what was that pop? It's another indication that the signal is being lost between here and here. It's a really serious loss. So that suggests to me, you know, because I did some component work back in there, maybe I boobed it up. Maybe I boobed it up somehow. Maybe the last guy boobed it up. Maybe I duplicated his boob up. How can we be more precise about exactly where things are dying out? How can we be more precise in there? Another possibility, yes, it could be the band switch. Okay, let's try the band switch thing again. if it's making no contact and it can't make any contact, then working it is not going to change anything. If it's actually just out of contact. So there's a big click, but we don't know. It's contacts here, and contacts here, all over the place. All kinds of them in here. So hearing it click, we don't know where it's coming from. At no time does it jump into full action. And most of the time a dirty switch, sooner or later, makes contact when you're doing this kind of thing. I mean, it's really, really consistent. Bad component placement. Mistake made in the radio. How did I get rid of the hum there? That's kind of nice. I'll have to explore that some more. I did in the meantime attempt a... that's lovely. No hum. I tried to isolate my audio system away with this old transformer. Then I realized, why do I have this transformer? Because it's dead. that's why I have it. If it wasn't dead, it would still be in somebody's radio. Okay, stream of consciousness, you know, goes all over the place. What can I say about it? Well, the reason I'm a little hesitant now is to get access to what's down below there. I have to remove these plates. These plates are precarious. They're barely held in. Every time you take them in and out, you run the risk of breaking off the screw terminal on them. I spent quite a bit of time putting these in very, very carefully. But I would have to pull it out to get back down in there. What if it's a like a cold? What if it's a cold solder joint? I can poke it. I can poke it. Poke it like this. Okay. So once again, man your volume controls, because if I hit it, it's going to get loud. I better man mine are already down a fair bit here. Okay, so that's a capacitor being poked. Get way down there. No, I don't think that's going to be the problem. Could be over on this side. Okay, there's one here. Poking. I'll have to poke this one. Seem to change just a wee bit there. Damage one of these coils poking around here too much. And just poking generally now. General pokage. Not much to poke down here. Yeah. Capacitor across the secondary. Let's let that go right into the new old SDR. We're listening to 10 megahertz. Go right on the capacitor, the tuning capacitor, which is on the secondary side of the coil. So one side is grounded through a capacitor and the other side is the live side. One side we should hear nothing, the other side we should hear lots. Okay, I'll do the easy side first. We won't hear it, we're going to see it. See it on the SDR. There's a 1 second delay on the SDR too. There we go. Oh, let me make a better connection here. Anything at 10? Yeah, there's something at 10. Let's try it again. Having a little bit of trouble finding a good spot to... and a lot of other stuff. if we come down here, see how strong that is? So that, I think I'm touching the primary side of this coil now. Secondary side is crap. Now maybe I was on the grounded thing. Let's see if we can get on the other end of this. Yeah. See, I think I was on the grounded end there before. This would be the signal side here. Well, there's a plenty strong 10 there. Okay, I come over to so the output from here should be pretty similar to the input there, I would think. No, that's not right. The output is going through a tube and then showing up over here. C17. Who knows what they're doing with all these odd capacitors in funny positions. And there's a capacitor running right between the coils. C17. How big is that? How big is C17? Just curious. C17. Oh, coupler condenser. That's the one that says coupler condenser. Doesn't give any value. C17. Well, you know, that capacitor should be right in here. Interesting, because I replaced capacitors in here. I put the size in that was already in. The last person changed them. Changed some of them. Maybe he made a mistake and I just duplicated his mistake. The size of this is not recorded anywhere. So what he took out is long gone. He put something in there. Or did he? I don't even know if this exists. Okay, let's go back to what we're trying to do. We're trying to prove the signal's getting to this primary. So there's some terminals here. I'm going to guess they are the right terminals. So here's one. You know, just, and yet no 10. Just the fact that the radio comes to life again just suggests there's a break between here and there. I think we're really zooming in on the problem here. Let me go on the other side of that coil. And on the secondary side, I'm not even looking at the SDR, I'm just listening. And we cannot find the signal in this coil. We cannot find it in the primary coil. We cannot find it in the primary coil. We cannot find it in this coil. But if we switch the bands, it's working through up here. But it's not working into this coil. So the switch is not connecting. A wire is off in here. Wow, I mean, this lead, the plate lead from here, must be conveying the signals it's receiving because it works on the other bands. Signal on the plate, signal on the grid. Why don't we look at what's on the grid? Did I do this already? Let's look at what's on the grid of this tube. How can we do that? Although this might kind of ruin the tuning of the radio when I go to do it. Especially with the SDR, maybe not. Maybe not. We'll try it. Grid cap of the 6K7 first RF. what is on the grid cap of that tube? Okay, grid cap of this tube. I gotta make a better connection here. Fingers and all. Okay, there we are. So this is the grid cap of the first. This is the grid cap of this tube, which should have the output from these coils. Now the radio went silent. That doesn't mean my signal generator stopped. It's still putting out its signal. Connect it onto the grid cap here. You know, the grid cap is right on the tuning capacitor on the coils. Good chance I just simply detuned this radio. So now we're kind of almost suggesting there's nothing getting to this tube. Not kind of, almost, we are. Well then this coil is implicated again. So let's poke through these coils again. Let me take this off the back here. It's really an antenna signal. It's a radio antenna input. Might as well be able to just hook this right on there. No ground connected on the SDR. Show me a 10. Where's the 10? Show me the 10. Oh, for God's sakes! I've look at. Yeah, should I even show you that? I'm using it. What a dumb move here. Okay, hold on. We gotta switch back here. Hold on. How much? Oh, for how long was I doing that? Oh man. It's kind of a dumb situation. Now what? I've got to, let's stick with this. Okay, 10 on the antenna. There it is. A beautiful 10 coming down there. 10 on the coil. 10 on the secondary. 10 past the tube coming out of this coil. I just keep proving the same thing over and over. I'm trying to focus it down. And there just isn't that much left now. So I'm finding it on the secondary. Find it exactly the same thing here that I find on the grid. They should look exactly the same strength. As long as I make sure I get on the right side of this coil. Because it's just basically a wire. Okay, let's try that. On the secondary looks like this. Yellow at 10. And then the grid cap on the it right. Grid cap on the 6K7. Right here. Nice strong signal there. I've killed the tube's operation, but the signal is there. So we want to look at what comes out of this tube now. It's just about impossible because the tube is way up in there. Well, I don't know, it's not so impossible. I did it yesterday, didn't I? Didn't I do that yesterday? So if we want to look at the plate, if the plate comes out to the switch here, where can I get at it? I have to go down and touch the contact. It'd be number 3. Pin number 3 shows the plate, and it's got a very high voltage on it. So maybe this will be the end of the SDR here. I'm going to stick this in the radio. Look at this thing I'm putting together here. Really? Try to touch this to 3, and then look at the SDR. Oh boy, that hum is coming and going again. 3. Oh my gosh. Need some light. I'm going to get right in front of the camera here to do this, I'm afraid. That's what's going to happen. 3. I can see the key there. 1, 2, 3. Wow. Okay, I think that's 3. Ah, man, I stick this down there, and then I gotta look over at the screen. This is pretty crazy. 3. Okay, I'm looking at the screen. What happened? See a huge signal at the local oscillator. Nothing at 10. Nothing at all at 10. Nothing too. So I think I'm on 3. I think that's the plate. Let's get out of there. I really threw the radio off. So I think I got on 3. What have I missed? Maybe I got on 4. Maybe I got on 2. 2 is a heater. It certainly was clearly in effect on the radio, so I'm pretty sure that was 3. I saw no signal. Where'd it go? Okay, let's just repeat that. Let's start with the grid. Through all this nonsense, and there's a strong 10 on the grid. This is the correct tube in the right position. Pin number 3 is the right pin. I'm just going to make absolutely sure now it was touching pin number 3. Where's that hum coming and going anyway? Okay, so 3 is really hidden from view. Just perfectly hidden from view there. Radio's on, Jim, don't forget. So I'm trying to see the key. I see it. I see the key. 1, 2, 3. That was definitely 3. So on the plate there's nothing. On the grid there's something. On the plate there's nothing. What the heck is going on? In a radio that works on all the other bands. How in the heck can any of this be? Man. The tube doesn't work at high frequencies. The capacitor doesn't work at high frequencies. You know, the low end of this band is the same as the high end of the other band. It's the same tube. I think that's too much of a long shot to even investigate. Oh, yeah. Just one more time to make sure I really understand what it is I think I'm finding here. Signal on the grid, nothing on the plate. Why would there be nothing on the plate? The plate voltage disappear? If the coil is open, no plate voltage. Okay, that's something worth looking at. Let's find my voltmeter here. If the primary coil is open, the plate will not have any voltage. Plate is 3. Around 1000 DC. Can I see it? Yes, I can. Okay, I'm gonna clip this one. I don't want to be holding two things when I'm doing this. Here. Okay, clip on the ground. So this is the open circuit coil test. Is the coil open? Pin 3, and what are we expecting? A couple hundred volts, maybe more on pin number 3. You're not going to see it if I get right in front of it here. Okay, I'm going to hold this. Just can't figure out how to set it down. Here. I can't see well enough. Where's the voltage? Okay, here we go. One band that's working. Man your volume controls. Okay, wasn't that exciting. Okay, here we go. Pin 3. $317 volts. I think we've reached a conclusion here. I think we've reached a conclusion, he says. Watch out now, don't get too excited, I'll end up having a shock. I'll throw something. Okay, what did we just find? We found the shortwave band very silent. If we happen to touch this coil, it seems to start receiving like somebody hooked up an antenna. If we put it on a working band, we check for B+ on the tube in there, it's there. We put it on the silent band, no B+. I mean, the only conclusion you can come to is open coil. Right there. That coil must be open. Power off. Get your own meter ready. Get your own meter ready. Here we go. Now, it's hard for me to know for sure. Oh. Can we really do this? Can we really do this? So, we don't know the resistance of the coil, but we can guess. A coil like that's going to be 60 ohms or something. It's a pretty heavy wire. I'm guessing the two contacts are just on either side there. And with the, according to this diagram and this switch, with the switch off this band, this coil is wide open on the leads. What's the other schematic say? Same switch. It looks like the same thing. It looks like the same thing. Currently, we're on that band. Let's see what we get with ohmmeter reading. Radio is off. It's been off for a little while now. Hopefully, you can see that right there. Not very often I found open coils in radios. So I would expect this to show a near zero on the ohm meter here. You can see it. And see, it's showing, it's on the 200,000 ohm scale, and it's showing open circuit. Now, is that really where you should contact these coils? Did I really get it across the coil? I don't know. Looking for something similar, you know. Yeah. Well, you can look at how these have been attached. They're just going down either side, just like that and that. I think I've proved it 3 times now. Three or 4 different ways I have proved that that coil is open. Well, there we are. That's where I'm going to stop today, because now I got to think about what to do about it. Right. So I've got to think now about what I should do about that coil. This is an important shortwave band. Just to talk a little bit about options. One option is to draw the coil right out somehow. Get the whole coil out of there and into my hand so I can work on it. Another possibility is all that's happened is a little bit of corrosion has roughed up the connections on either side, and a whack with a soldering iron might bring this guy back. Close examination, I may be able to see the actual wire where it comes out of the coil and goes to the contacts. That could be happening internally inside the form where it's not visible. The wire on the coil on the outside, you can poke down through a hole. You can see it happening right there. And then the connections are made inside the coil. You can't see them. A careful examination of what part of the coil I can see may reveal damage. Damage is quite possible on the upper surface here or anywhere in here. A fellow and me too, we both worked with a soldering iron right past this coil. We could have touched it. Wouldn't think that would necessarily open it. But I'm pretty sure it has to be the coil itself or these 2 connections, the solder ends of the coil wire. It's got to be there. It can't be further up in the circuit. It's got to be there. And it looks like removing that is a monstrous thing. Taking something like this out and putting it back in, you know, you run a lot of risks. It's a big disturbance to the radio in an area where you're not really supposed to disturb it. We'll see what we can do with it just sitting right there. That's got to be the best approach. But that's for tomorrow. That's for tomorrow. So thanks a lot for watching. It's been a pretty crazy video, the last couple videos, but ultimately I've got to where I need to get to, which is what I've learned. If you just keep at it, you will get there. Have a great day.